NASA launches a rocket at t equals 0 seconds. Its height in meters above sea level is given by the function h of t. When will the rocket reach its peak height of 400 meters above sea level, round to the 10th place value? This is a very straightforward question, as long as we recognize that first h of t is a quadratic function, and second, the 400 meters is the peak height. Looking at our notes below, if we have a quadratic function in the form f of x equals ax squared plus bx plus c, where a is negative, notice in our case a is equal to negative 4.9, the parabola opens down as shown here. Looking at the graph, this high point here is called the vertex of the parabola. This is where we have the maximum output or the maximum function value, which means in our case tells us the peak height of 400 is the output or function value at the vertex. And we can verify this by looking at the graph of h of t. Here's the graph of the function h of t, and notice how the maximum height here is 400 meters. And we're asked to determine when this occurs, which means we're looking for, in our case, the t-coordinate or the input of the function that will give us the output of 400 meters, which again occurs at the vertex. And when our function is in this form, we can use this formula here to determine the vertex, where the input or x-coordinate, or in our case the t-coordinate, is equal to negative b divided by 2a, and the output or function value is f of negative b divided by 2a, or in our case, h of negative b divided by 2a, which we already know is equal to 400. So if we recognize we are looking for the vertex, this is a very straightforward question. Again, where the vertex has an input or t value of negative b divided by 2a, and the output or function value is h of negative b divided by 2a. In our case, we already know that the output or function value is 400. So by determining the t-coordinate of the vertex, we can determine when the rocket reaches the peak height of 400 meters. So t is equal to negative b divided by 2a, where in our case a is equal to negative 4.9, b is equal to 52, and c is equal to 262. So we have t equals negative 52 divided by 2 times negative 4.9. Simplifying, 2 times negative 4.9 is equal to negative 9.8. This gives us negative 52 divided by negative 9.8. And now determine the quotient on the calculator and round to the 10th place value. We enter negative 52 divided by negative 9.8. Press enter. Notice we have a 3 in the 10th place value. The digit to the right is a 0, which means you round down. The time is approximately 5.3 seconds. So the vertex is the ordered pair 5.3, 400. If we go back to our graph just for a moment, notice how the t-value of the vertex does appear to be approximately 5.3. To answer the question, the rocket will reach its peak height of 400 meters at approximately 5.3 seconds. Now before we go, I do want to mention that we could have solved this problem by setting h of t equal to 400 and then solve the resulting quadratic equation, but that would require the quadratic formula and quite a bit more work. I hope you found this helpful.